For the better part of a decade, the world of high tech has kind of run on a simple assumption: the most advanced computer chips on the planet. They'd come from one place. Well, that assumption is now being completely shattered. What we're witnessing is a fundamental shift in technology, a super high stakes global race that's literally going to define the future of computing.
Yeah, what you're seeing here isn't just some headline. It's basically the starting gun for a whole new era. The long-held dominance in chip manufacturing, it's being challenged, creating this historic inflection point. This is the story of how that happened and what it means for everything, from the phone in your pocket to global politics.
So how in the world did we get here? Well, for over 50 years, the industry followed this sacred rule. You've probably heard of it, Moore's Law. Just relentlessly shrinking transistors to make chips faster and more efficient. But now we're hitting a very real, very physical wall.
Just look at this timeline. It shows that incredible march of progress. We went from 22 nanometers in 2012 all the way down to just 3 nanometers in 2022. It's just wild. But as we get down to the atomic scale, the transistor design that powered this whole journey is just, well, it's running out of room. The reliable playbook is finished.
Okay, so the hero of the last decade was this little guy, the FinFET transistor. Think of it like a valve. To control the flow of electricity, the current, it pinches the channel from 3 sides, kind of like how you'd pinch a garden hose. It was an absolutely revolutionary 3D design that fueled the entire smartphone era. But at these new, impossibly small sizes, it's starting to leak, and that wastes power and kills performance.
So, the end of the FinFET era has basically blown the doors wide open for a new contest. And this isn't just some corporate rivalry. Oh no, this is a 3-way global race for technological supremacy.
In this race, you've got 3 main players. First, there's TSMC from Taiwan. They're the undisputed defending champion, the foundry that builds chips for giants like Apple and NVIDIA. Then you have Intel, the American titan that pretty much invented the microprocessor, and now they're fighting for a massive comeback. And finally, Samsung from South Korea, the ambitious challenger who's willing to make some really bold bets to try and grab the lead.
So what's everyone fighting with? If FinFET is the old weapon, then the new arms race is all about a revolutionary change in how these transistors are actually built.
Now, this is where it gets really cool. Remember that garden hose analogy? FinFET was like pinching that hose from 3 sides. The new architecture, Gate-All-Around or GAA, is like wrapping your entire hand around it. The gate now surrounds the channel on all 4 sides, giving it near-perfect control and drastically cutting down on those energy-wasting leaks. This, right here, is the key that unlocks the door to 2 nanometers and beyond.
But a new transistor isn't the only trick up their sleeves. While all 3 companies are moving to some form of GAA, Intel is pairing it with a secret weapon called PowerVia. It's a pretty radical idea. They've moved all the power delivery wiring to the back of the chip. Think of it like separating the power lanes from the data lanes on a highway. This reduces interference and lets chips run faster at lower voltages. It's a massive, massive gamble.
Okay, so with these new technologies in hand, the battle for the 2 nanometer generation is officially on, and it's all going down between 2025 and 2026.
And this table really lays out the state of play. You've got Intel making a super aggressive move with its 18A process, using that new backside power to win over giants like Microsoft. Meanwhile, TSMC is doing what it does best, refining its GAA process for its loyal heavy hitters, Apple and NVIDIA. And Samsung is right there too, powering its own devices and partners like Qualcomm. For the first time in years, it's a genuine 3-horse race.
But here's the thing, their strategies are different. TSMC is betting on its traditional strength, density. Its N2 node still crams more transistors into the same tiny space, which has always been a huge advantage. Intel, on the other hand, is betting that its PowerVia tech gives it better performance per watt, basically arguing that how efficiently a chip runs now matters more than just raw density. This all comes down to manufacturing reality, right? This is a crucial point. TSMC's legendary reliability means it's starting with slightly better yields. That means fewer defective chips per wafer. And at scale, that is a massive advantage. Intel's more aggressive brand new design has slightly lower yields to start, but they believe the performance boost is totally worth the challenge of ramping up production.
So why does this tiny microscopic battle matter so much? Because the winner doesn't just get bragging rights. They get to shape the future, from the device in your pocket all the way to the balance of global power.
Whoa, look at this number, over $30,000. That's the price for one single of these advanced silicon wafers, which then get cut up into hundreds of chips. This isn't just a technology race, it's an economic war with an unbelievably high barrier to entry. At these prices, only a handful of companies on Earth can even afford to play the game.
And here's why governments are paying such close attention. As of 2025, over half of the entire semiconductor market is concentrated in the Asia-Pacific region. That concentration is seen as a major supply chain risk, which is why you see nations scrambling to build up their own domestic manufacturing.
The prize they are all fighting for is just staggering. The semiconductor market is projected to be worth nearly $1.5 trillion within a decade. Control of the most advanced nodes means you control the most valuable slice of this massive trillion-dollar pie. It's as simple as that. So let's connect the dots here. Whoever wins this race doesn't just sell chips, they set the tech standard for the next decade of AI, cloud computing, you name it. A win for Intel validates huge government investments like the CHIPS Act, and this whole competition is inspiring new players like India to jump into the game. This isn't just about faster phones, it's about redrawing the technological map of the world.
But here's the thing about technology. The finish line is always moving. The battle for 2 nanometers is really just the prelude to the next great war.
You better believe all 3 of these titans are already hard at work on the next nodes, 1.6 and 1.4 nanometers. They're exploring radical new ideas, like stacking transistors on top of each other, using totally new materials beyond silicon, and deploying these next-gen, multi-million-dollar machines to print these impossibly small circuits.
So the race to 2 nanometers has crowned new contenders and reshuffled the global order. But it leaves us with an even bigger question. As we get so small that we're literally counting individual atoms, the strategy can't just be about shrinking anymore. The future, it's going to belong to whoever can innovate in materials, in architecture, and in dimensions we're only just beginning to imagine.